Hello and welcome to this introduction to CloudConveyor. This video will demonstrate the CloudConveyor services and introduce how a migration factory can help reduce the risk of migrating applications and accelerate the adoption of cloud services. The market adoption of cloud services is growing each year. Through the decision engine, CloudConveyor can automate and simplify the processes required to match applications to the most appropriate cloud. Enterprises must make a significant number of decisions to adopt cloud services. These decisions must also consider the changes that are needed to successfully migrate and balance the cost and risk of change. The migration factory process integrates discovery tools, a migration repository, the decision engine, and execution tools to provide an enterprise-class migration management platform with processes that offer an end-to-end solution to cloud migrations. As the decision engine is harnessed, the same structured approach can be used to determine possible destinations for workloads and the transformations required to reach those destinations. The decision engine is a data-driven service with optional user interface that asks questions, determines requirements, and then makes recommendations based on those requirements. This example application assessment is based on a CloudConveyor engagement with one of our customers, but has been simplified to better demonstrate the process. In this engagement, the decision engine is used to determine suitable cloud platform targets: public Amazon Web Services, a private OpenStack based cloud, or to simply consider virtualization to the existing VMware estate. Where an application can migrate to a cloud destination, a high, medium or low complexity is calculated. Applications that cannot take advantage of cloud benefits will only be considered for virtualization. Application assessments are typically very time consuming and rarely complete. The aim is to determine answers as quickly as possible with minimum effort. Efficiency is achieved through the design of the decision engine and also the stages of assessment. We identify the applications not suitable for cloud migration early in the process before investing in more detailed analysis. The migration scope includes all applications that are currently hosted in the data center. This simple example involves 3 decision gates for determining possible cloud destinations. Each gate requires more analysis effort than the previous one. The first gate involves an initial assessment to determine if the application can migrate to cloud and how complex that migration might be. Applications that are not suitable for cloud or technically cannot migrate will be considered for virtualization. If an application can be migrated to cloud, it may pass to Gate 2. This gate analyzes dependencies on infrastructure and other applications. For example, if an application has a latency-sensitive dependency on another application that cannot migrate, they will both be prevented from migrating. The final gate is the business case. This involves the most effort to analyse, but the previous gates have minimised the candidates so we can focus our resources on this labour-intensive activity. If the business case is not viable, applications may still be considered for virtualisation, but if it succeeds, migration can be recommended. Information gathered throughout the discovery and analysis can now be fed into migration execution tools. For Gate 1, we are using the decision engine to determine if an application should migrate to one of the cloud destinations or just be considered for virtualization. When migrating to cloud, a complexity rating is also calculated. The decision engine is configured with the required answers. Consider virtualization, OpenStack, AWS, low, medium and high complexity. Each answer is related to outcomes calculated by the decision engine. For example, virtualization should be considered if the application does not leverage cloud functions. The user of the decision engine may not know what leveraging cloud functions means. Simpler questions are asked that enables the decision engine to calculate outcomes. The engine is configured to only ask questions that help determine possible answers and calculated outcomes. For example, if the application will not leverage cloud functions, the application should only be considered for virtualization. The other targets and associated complexities are no longer possible, so no more questions would be asked. This demonstration will show the decision engine at work using the configuration explained in the example application assessment. The first question is rather an obvious one with an obvious effect. In some cases, the user knows that an application simply cannot migrate to cloud. If there is a known reason, the engine completes with a recommendation that the application should be considered for virtualization. However, if we change the answer to no, the search for a cloud destination continues with the next question. The next question is regarding the certification requirements. If the application needs to be certified, but that's not possible, the engine also completes with a recommendation that the application should be considered for virtualization. Selecting one of the others will have an impact on migration complexity, so for now we will select no certification required. Only stable applications can migrate to cloud, so here we'll select that option. Only applications that will take advantage of cloud functions will be migrated to cloud, so here we will indicate that the storage is not predictable. The engine moves on to ask questions about the data center location. If we move back and change the predictable storage answer, the engine will not have determined if the application requires cloud functions, and the next question changes to ask about the processing requirements. We'll select that the processing profile is not steady. Location questions can now be asked. We will indicate that there is no requirement to host the application in the data center. This results in Amazon Web Services still being a possibility, so the engine checks that the Amazon Web Service locations are suitable. We'll select Ireland as a suitable location. If we go back and change our minds to show that the application must reside in the data center, the question we just asked would be irrelevant. The decision engine retains the answer, but it's ignored and disabled. Retaining the answer is useful if we change our minds again. Ireland is still remembered and now takes effect again. The next questions are regarding any middleware components. We'll indicate that our application does indeed integrate with a middleware component. And that latency sensitivity is an issue. Because latency sensitivity is an issue, we need to determine how integration can take place. Selecting that the application must integrate with an instance in the data center would mean that Amazon Web Services is no longer an option. Selecting integration can take place with an instance currently hosted in AWS indicates that the application can be installed in AWS and no extra work is required. Selecting integration with a middleware instance in AWS is possible, but the middleware needs installing will result in AWS being possible, but the complexity will increase. We'll select that final option. Next, we need to determine if the current operating system and database is suitable for cloud environments. We'll select a suitable operating system and no database for now. The decision engine has determined that OpenStack Private Cloud and Amazon Web Services are suitable destination for the application. The decision engine has determined that OpenStack Private Cloud and Amazon Web Services are suitable destinations for the application. Now the only questions being asked are to determine the complexity. To achieve the lowest complexity, we will select that hostnames and IP addresses are in configuration files. The application is stateless, and a version exists that is OpenStack compatible. Now the engine has completed and the complexities have been determined. You'll notice that the AWS migration is a higher complexity. This is because we have to install middleware components. If we go back and change that to indicate the middleware already exists in AWS, the complexity should be reduced. There you can see that the AWS migration is now low complexity. We will now change the answer to this last question to indicate that a version of the application does not exist that is OpenStack compatible. The complexities are now removed because to determine complexity, the engine needs to ask another question about the architecture of the application. If the application is already scalable, the complexity is higher than if we had an OpenStack compatible version of the software. If we change to no, the application needs completely re-architecting and the complexity is increased to high. The power of the decision engine is also harnessed by the migration factory using the published APIs. To introduce the concept, the factory is a framework of processes and swappable tools that integrate through defined interfaces to support discovery, analysis, service selection, planning, and execution of migrating workloads. Migrating applications carries risk and significant cost. Migrating to cloud adds to that complexity as there are more technical and operational considerations. The number of dependencies between multiple applications, infrastructure and services contributes to the complexity. Not understanding and structuring dependencies increases the risk of migration failure. A proven methodology and toolset is required that guides a program through the end-to-end migration process, from discovery to execution. Industry tools do exist for some of the migration steps. Consultancies and systems integrators need to leverage the efficiency of a tried and tested process with the flexibility to address customer requirements. Industry investment has tended to be focused on fixed tools owned by a single organisation. This approach often runs into challenges when implemented in an enterprise with their own tooling or integration requirements. For example, discovery tools are often mandated as they are already in place. The Cloud Migration Factory is an integration platform that provides an end-to-end process using swappable tools. Common industry tools are certified to deliver discovery and migration capabilities. If another tool is required, integration and certification processes are key differentiators of the factory approach. The Migration Factory is built on a well-defined reference architecture. Firstly, the portal. This is a single user interface that migration planners and engineers use to interact with the factory. It's used to configure the factory and integrate tools. Once the tools are integrated, it's used to manage migrations by initiating discovery processes, making and recording decisions, planning and executing migrations. Many of the functions initiated by the portal and the factory will require multiple coordinated steps. Those steps will be managed through the orchestration function. The Migration Factory uses existing software where possible. We don't reinvent the wheel. These high-level cross-platform functions are no exception. Once the migration program has been established, some level of discovery is required. There are many industry tools that can discover application and infrastructure data. CMDBs and even spreadsheets will also be sources of information. The problem with discovery tools and CMDBs is they contain information not required for migrations. Too many migration projects start with fixing the CMDB. That's a project in itself. Also, multiple data sources may provide the same information and it's not clear which is to be used. A central repository of migration-specific data that acts as a single point of truth for the whole migration program is required. Discovery tools are always prime candidates for being swappable between migration projects. The factory architecture includes an interface between the discovery data sources and the repository. In the Migration Factory architecture, sockets are created for each data source. The socket will define the capture method of the data source, the data being sent to the socket, and the mapping to the repository data. A socket management function is also provided that can define rules such as how data conflicts between multiple sockets should be handled, identify gaps in the repository that are not being filled by any data source, and also general management of the sockets, such as data being received that does not match the registration details. Once the data is captured, decisions need to be made. Often there are multiple destinations, each with multiple transformation requirements, such as OS upgrades. The decision engine uses the repository data to inform those decisions and to identify gaps in the repository that are preventing key decisions from being made. Once those decisions are made, they are recorded back in the repository along with planning activity that is prepared using key reports in the portal, such as suggested migration groupings of applications. Once the decisions have been made, migration can take place. Rarely is migration a single step. It can involve migrating a whole server, migrating and synchronizing data, raising change controls in the client's organization, and reporting migration problems to the engineers. So, the factory has these two functions. One is to execute migration tools that affect a change directly in the data center, and the other is to integrate with existing client management workflows such as change control. These migration tools also need to be swappable and certified. In the same way that discovery tools are integrated with the factory using sockets, a similar approach is used for execution. Execution methods and data requirements for each tool is registered in the sockets. An execution socket management function is also required to associate migration methods with multiple execution tools. The CloudConveyor Migration Factory is pre-configured to integrate with certified discovery and execution tools. Processes, migration methods and reports are built into the factory to define a tried and tested methodology. In the migration market, consultancies differentiate based on their methodologies and often develop tools to supplement and manage their own processes. Software development is usually outside the core competency of the migration consultants, and in-house developed tools are expensive. Unless a DevOps process is continually implemented, in-house software can be restrictive and reduce agility when changing processes or meeting new customer requirements. The Migration Factory is completely configurable. It allows consultancies to apply their own methods in a structured way to complement the core migration capabilities of the factory. End client requirements are also met by integrating the factory with internal processes and delivering client-specific reports. The factory can be white-labelled to deliver an interface that is branded by the migration consultants and the end client. By using the factory, migration consultants can focus on their core business of migrating workloads without the burden of developing and maintaining a complex software product. To the client, they are receiving a migration service that is designed to reduce risk and has been tailored to meet their specific needs. In summary, CloudConveyor is a data-driven decision engine that's used to effectively drive users to selecting the right cloud services. It's integrated with a cloud migration factory that provides a framework for integrating migration tools to deliver an end-to-end process for migrating workloads. Finally, thank you very much for taking the time to listen. If you have any questions, please contact info@cloudconveyor.com.